between absolute, relative, and weak discernibility. Okay, so here's the idea. Absolute discernibility is when you have a formula free in one variable that's satisfied by one individual and not the other. So everyday material objects are like that. There's plenty of formulas we can give containing a whole load of description of a whole load of properties, and then this table satisfies them, that formula, and that table doesn't. Okay. Natural numbers are like that. Using the successor relation, we can attribute a unique state, a unique formula to every natural number. Classical particles in a sufficiently asymmetric universe are also absolutely discernible by their spatiotemporal trajectory. Okay, so even if they have all the same intrinsic properties, doesn't matter, because this doesn't restrict us to only considering intrinsic properties. The formula in question can have bound variables in it. So we can talk about the thing's relation to other things, but that must all be bound, and then we just have one free variable. So x is that particle that stands in all these relations to all these other particles. Okay, so what's relative discernibility? Well, that's when you have a formula free in two variables satisfied by the objects in one order only. So if Tim's right that time has an intrinsic direction, but suppose that the instants of time are intrinsically the same as each other, right, then two instants of time are relatively discernible by the before-later bound relation. And if we have a set with a linear order, same thing. Okay? And then weak discernibility, this is the one I'm not going to be interested in relative discernibility anymore, really. Mostly I'm just going to talk about these two. Okay, weak discernibility is when you have an irreflexive formula free in two variables satisfied by the two objects together. So it might be symmetric now. So the famous example of the famous alleged counterexample to PII due to Max Black is an empty universe with two solid spheres that are 2 miles apart and intrinsically exactly the same as each other. They are weakly discernible because the relation 2 miles from is satisfied by them, but not by them when you substitute both of them into that formula, but neither of them is 2 miles from itself. Okay? And likewise, I and minus I. Well, I is the additive inverse of minus I is the additive inverse of I, but I is not the additive inverse of I, minus I is not the additive inverse of minus I. They're also weakly discernible. And two fermions in the singlet state, Simon says, they satisfy this too because take the relation has opposite spin in the x direction. Right? Then particle 1 has opposite spin to particle 2, it doesn't have opposite spin to itself. Now, let's leave to one side the question as to whether this is really properly called discernibility. Okay, in fact, I don't think it probably isn't. Right, but I'm going to tell you about the logic of, something about the logic of discernibility relations, and I don't really care whether they're properly called discernibility relations. That name has stuck. We can compare these relations according to how discerning they are. Okay, so obviously it's natural to say that one discernibility relation is more discerning than another if there are objects that are discerned by the former but not by the latter, and not vice versa. No, sorry, I didn't say not vice versa. Okay, so weak discernibility is obviously more discerning than absolute discernibility. Right? Because we've already given examples of things that are not absolutely discernible but are weakly discernible, like I and minus I. It's also true that whenever two objects are absolutely discernible, they're also weakly discernible. So, what we've been investigating in Bristol is the relationship between the questions about discernibility as they appear in philosophy and how they appear in model theory. So, and this is because, remember I was saying that you might not like talk of individuation. and you might not like talk of in virtue of, and ontologically depends on, all that stuff. Right? And most people are happy with the idea with entailment. So we can add some rigour and precision to the discussion by asking questions about what you can deduce in, if you have languages of different strengths, what facts entail what other facts. So in model theory you consider a language, a domain, an interpretation function. And all talk of discernibility, even if I forget to say it, from now on is discernible in a language L. Okay. So what we want to link, talk about languages to the philosophical questions that we're interested in to start with, is some condition on a language being apt for the domain in question, let's say being expressively adequate. Right? But our notion of expressively adequate, I mean, this comes from model theory, but it's adequate gives the wrong, has the wrong connotation, because you know, I wouldn't necessarily be particularly pleased if Barry said to me afterwards that my talk was adequate. Whereas the notion that we have here is a notion of, you know, is just perfect. Okay. So that is to say, let's call a language sound if the distinctions you can draw in the language correspond to real distinctions in the world. And let's call a language complete if the distinctions that are there in the world can be drawn in the language. Right? Then we're going to call a language adequate if it's both sound and complete. And that means just fits just right. Okay. So to give you an example, people object. In the classic Max Back paper, one of them says, look, of course they satisfy PII because Castor's 2 miles from Pollux. Pollux isn't 2 miles from Pollux. Right? But then the other person says, no, you've illegitimately introduced a name. You're not allowed to do that without presupposing various things, right? So the objection there being made is therefore you have used a language which is not sound, right? Or suppose I talk about PII and I use hexates. I use properties like that. The property of being A, right? Then you could say, look, there aren't really hexates in the world. I don't believe in that kind of metaphysical stuff. So your language has resources you're not entitled to. Your language is not sound. On the other hand, suppose your language lacks predicates for hexates, and you're a metaphysician who's convinced yourself that of course there are hexates. Then you're going to declare that language to be incomplete. And if we used, in proving that quantum particles were satisfied PII, if we use purely mathematical properties, then you might think, okay, that's not sound, that's an objection. Good, okay, so I've got an example in a minute that alright, so I've already said this, okay? So we'll focus on definability or entailment facts rather than talk about ontological dependence or determination or supervenience. Okay, so here's an example, right? So this is sort of fixed what I'm talking about by about soundness and completeness and stuff. So consider a language with 2 objects, Gödel and Tarski, and 1 relation, and this relation just it relates each of them to themselves and to each other. Then clearly Gödel and Tarski are indiscernible in that language, right? But Gödel and Tarski are not indiscernible, so that language was not adequate. Okay, so that's the kind of thing I'm talking about. So, for example, if you're a physicalist, you might think, right, so physicalist language is adequate, right? It covers everything that there really is, and it doesn't include too much. Whereas language that talks about hexates or whatever is It covers everything that really is, but it covers a load of other stuff that it shouldn't, because that stuff doesn't exist.